Hello everyone, Harsh here. So we are going to talk today about this demo between a private swap between Zcash and Aztec. And this is a problem statement that I've personally been very interested by because you can do so much with it. So to talk about firstly the problem, right now the most basic thing that people do with the Zcash is that they buy and sell it. And that's the most basic behavior you can do apart from just sending it directly on Zcash. And the current solution for exchanging Zcash has been near intense if you don't want to go through a centralized exchanges route. So the problem with how intents are working right now, like near intense, is that when Alice wants to send Alice money on Solana, so for example, in this specific illustration, Alice basically sends some ZEC to the Zcash address of intent solver, and that doesn't leak anything to the intent solver on who Alice is on Zcash. But to get her money on Solana, she has to provide her address on Solana, and that makes the intent solver aware of who Alice is on Solana. And right now, because near uses transparent addresses, near intents uses transparent addresses, basically anyone can see that someone sent this much ZEC and someone sent got this many USDC on Solana, and they can link these two transactions and know that Alice got her Solana because of this specific transaction that happened on Zcash. And that leaks privacy, right? And I think there's a better way to solve it. I think you can create a system where the intent solver doesn't get to know who Alice is on Zcash. The intent solver also doesn't get to know who Alice is on Aztec, and the transaction graphs are completely private. And this is possible with Aztec, so that's why Aztec is gonna be the chain where we are assuming Alice is now going to receive our funds. So let's discuss the solution of how it would work. So the unique unlock here is the concept of partial nodes, where right now when you have to accept any amount of digital assets on some other chain, you basically provide your address and then someone pays to it, but the act of providing your address basically reveals who you are. But here, in our specific case, Aztec uses the UTXO model, and we have a concept of partial nodes, where a partial node is basically just like any other node out there with some information not completed at that point of time. So for example, here, if there's a node which has an owner and what asset this node represents but doesn't have an amount, then that's a partial node. So for now, for users, like for readers' simplicity, I will say you can assume that a partial node is a primitive that allows you to receive money on Aztec without the other person knowing what your address is. So you can provide them this partial note, and they can basically put any amount in it, and they know what asset they're paying, they know how much they're paying, but then they won't know who you actually are, right? Like, so that part remains hidden. So that's like a very basic understanding of it. It is not the most technically accurate description of it, but it's beyond the scope of this article. For now, just assume partial note allows you to receive money on Aztec or receive any digital asset on Aztec without the other party knowing who they are paying to. They just know that how much they are paying and what asset they are paying to. So that's a unique unlock here, where now what happens is that if Alice wants to sell her Zcash, which is like ZEC on Zcash, and get some USDC on Aztec, then she will firstly generate a partial note, the payment to which will basically come back to her on Aztec. So she will create a partial note, and she will privately pay here to the Zcash address of the solver, and in the memo she can attach her partial note address, right? So basically now when the intent solver checks if the payment happened or not, the moment it says, oh, the payment has happened, it looks, oh, here's the partial note address, but the partial note address doesn't let the solver know who Alice actually is on Aztec. So the intent solver can then pay the required amount of USDC to the partial note of Alice on Aztec, and this act will provide back the USDC to Alice without the intent solver ever knowing who Alice is on this specific in this specific scenario, right? Like on Aztec, who Alice is remains completely hidden. So here everything is private because it's a shielded transaction, and even if it was a shielded to transparent transaction, the solver doesn't get to know who Alice is. And then because we are using partial nodes, the solver doesn't know who Alice is on Aztec. And because these are both private transactions, if someone looked at the block explorer of both the chains, they won't be able to know what's they won't be able to link any two transactions, right? Like the whole order flow also remains private. Like the only person who's aware of the order flow and the transaction graph would, for any specific transaction, would just be, let's say, Alice and the intent solver. But for the rest of the world, even that remains private. So it's really, really cool. Okay, so now enough of me talking about all of this. Let's just do a really super quick demo of it. Before I do the demo, one last part would be, how does the other side works? It's pretty intuitive. Basically, Alice will pay to the solver, let's say. And what I mean by the other side is, if Alice wants to basically sell some USDC to buy Aztec, so the exact opposite will happen. Alice will pay to the address of, to the partial node of the solver, or can make a private payment to the solver. It's upon how solver wants to do it. And then the solver will do a shielded transaction to an mphill address of Alice. And since mphill addresses on Zcash are rotated per transaction basis, the solver doesn't get to know who Alice is on Zcash. So you can maintain these privacy guarantees that I have presented here on both sides. Okay, cool. So demo time. So right now we have two web apps here. We already have a solver running in the background. We already have like a solver, like an intent solver, both on Aztec, like solver software both on Aztec and Zcash running in the background. So if you look here, like I come as a user and I'm like, oh, I want to sell 0.01 of my Zcash or any random amount for here, and I want to get 100 USDC on the other side. So I will come and on this website, and the solver will say, hey, this is the address, like the shielded address where you have to pay, and if you pay me money there, I will give you your USDC on Aztec. So I will come to this web app and I can see my current USDC balance on Aztec is 0, and I will say, okay, let me just create a partial node. So I will come here and I will create a partial node. So it's creating a partial node on Aztec for Alice, or like for example here me, to be able to use on this specific scenario. Okay, cool. So here it is. Yep. So I have copied it and providing this address, so this is actually a contract address which is wrapping a partial node, but this doesn't leak anything about who I am on Aztec, right? So I will come here and say, give me the amount 100. Another small thing is that actually, you do need to put the amount here. Yeah, sorry. Cool. Yep. So I will come here and I say, okay, cool. I will send some asset to this specific address of yours, and you have to give me 100 USDC. I have made sure that my partial node does check that I get paid 100 USDC. So this will make sure that the solver has to pay at least this much, or the partial node would get completed. So, yep, let's do this. So I have a Android emulator working here, and I have a Zcash wallet. This is the only one that works with a testnet, so I'm just gonna use this one for now. And I will copy the address. I will come here and paste this. Okay, cool. And then I will say, you can right now send any random amount and it will work. But in reality, like we would be using some sort of an oracle to do price checking. Okay, cool. So I will come and say send and confirm. So now it's basically creating a local ZK proof, and then it's gonna send the transaction to testnet. Here I will say submit, and now it's waiting for confirmation, waiting for this transaction to happen on Zcash. So yeah, so now the transaction has been emitted, and if I go to the Explorer, I think there should be a transaction now in the mempool. Yes, our transaction now is in the mempool. So we are now gonna wait for this transaction to be mined, and the moment this transaction will be mined, it will say confirmed and it will give 100 USDC to the specific web app. So let's wait. Did do so. This could take some time. I think what's the block time here? I guess it's a minute or so. So I think like in a minute it should get confirmed. It's now 42 seconds. So like 15. And if you're seeing this video, you can just like fast forward it like by 10-20 more seconds, I'm assuming. Okay. 1 minute is done for this transaction. And I think it should ideally be mined by the next block. Like yeah, assuming 756. So yeah, it should be ideally. We just wait for one block confirmation. Ideally, we would be waiting for more, but for the sake of the demo, even if we get one block confirmation, we right now confirm it. But that's just for demo. And yeah, I think in sometimes, like when the next block will be produced, this transaction should be confirmed. We are still waiting for confirmation here. Okay, cool. It looks like it has been. So yeah, here it says, congratulations, your private swap was successful, and my USDC balance. Tell me I got paid. Okay, I think there's a small mistake where, let's say, we probably weren't running the. Okay, it looks like we are. So then why is my balance not? Oh yeah, it's there. Sorry, it was a small lag. But yeah, so here you can see I was able to get 100 USDC on Aztec by privately selling some Zcash on the Zcash testnet. And yeah, if this is intriguing to you, do check out the write-up that we have released on Twitter. The code base is available here on Aztec Pioneers, and if this is something that you find really interesting, more than happy to chat on Twitter or wherever you want, and more than happy to help in whatever capacity you want. Yep. Thank you.